Red dwarfs are by far the most common type of star in the Milky Way. That automatically makes them a prime target for the search for alien life. But how would a habitable planet around a dim red dwarf star actually look like? How would it be different from Earth? And how would life, climate, weather, and maybe even society, culture, and religion look like? That's what we will find out in this video. First up, we need to actually build a red dwarf star. If we really want to experience the real red dwarf feeling of a very dim, tiny star that can shine for trillions of years, we need to go on the lower end of the mass. About 12% of the sun's mass should ensure that our star will live for a few trillion years. Now, when calculating the habitable zone of the star, we typically just take the square root of the luminosity and multiply it with two different factors for the inner and outer boundaries in AU. There are two main sets of factors for calculating these boundaries: the conservative habitable zone, which is based purely on theoretical calculations, extends from roughly 0.9 to 1.4 times the square root of the luminosity of the star, whereas the optimistic habitable zone, which is mainly based on the assumption that Mars and Venus used to have liquid water on their surfaces a few billion years ago, which most scientists today agree on, extends from roughly 0.8 to 1.7 times this value. Anything within the optimistic habitable zone can be habitable, although planets within the conservative habitable zone tend to be more Earth-like. But as you'll soon see, nothing in this system is even remotely going to resemble conditions that we're used to here on Earth. However, since red dwarfs are very dim and their habitable zones tend to be very close to the star, tidal heating from the star might actually play an important role in heating up the planets. Unlike in the solar system, where tidal heating between the Earth and the Sun is essentially negligible, in this system, tidal heating from the star could very well push the inner and outer boundaries of the habitable zone outward by about 10%. Now that we know the habitable zone boundaries of this star, we can move on to a significantly bigger problem: flares. Red dwarfs are fully convective and don't have a radiative zone like the Sun. This is one of the reasons why they live so long, but it can also lead to powerful stellar flares. While we know today that these flares typically occur at the poles of the star rather than the equator where planets orbit, we still need to ensure that our planet's atmospheres don't get blown away by these stellar flares. Firstly, we need our star to be very old, as the older a red dwarf gets, the less frequently it flares. For our star, let's give it a really old age of 12 billion years, which also means it likely has a very low metallicity. The planets should also be significantly more massive than Earth. More massive planets are more likely to retain a strong magnetic field and a lot of geological activity. Both are vital for a planet to be habitable. This is the trap that Mars fell into. We also need to be careful when going for a mass and radius that the density of a planet will be comparable to that of Earth. Otherwise, it might be a pure ocean world or even a gas planet, which is not what we want. What we want is a rocky terrestrial planet with continents and oceans, similar to Earth, just significantly bigger and more massive. With all these ideas in mind, let's give our star a few planets. I'm going for a total of 5 planets. The first planet is basically a bigger Mercury, an airless rock that formed very close to the star and didn't really get a lot of material from the protoplanetary disk. As a result, its atmosphere was immediately stripped away by solar wind. Temperatures vary between over 300 degrees Celsius on the day side and minus 200 degrees Celsius on the night side. Oh, I forgot to mention, all planets are tidally locked to the star, which means they always show the star the same side, just like the moon does to Earth. The second planet is a lot bigger and more massive, and has successfully held onto a thick atmosphere of mainly CO2. It's a massive Venus on steroids, with temperatures of over 800 degrees Celsius, hot enough to melt lead and aluminum, even on the night side. The next 2 planets are our habitable worlds. They both have nitrogen-oxygen atmospheres, similar to Earth, liquid oceans, and continents. I will go into more detail later about how life on these planets would look like. The last planet is a frozen ice world with a hell lot of water and water ice. It mainly consists of a frozen surface with large bodies of water underneath, similar to Europa or Ganymede. Its atmosphere is almost entirely nitrogen with very small amounts of oxygen and carbon dioxide. Now that we know all the planets, what would life actually look like on the two habitable planets? First up, forget the moon. Instead of seeing a moon, people standing on one planet would be able to see the other planets, not just as distant dots of light, but in detail, their surfaces. The star would also appear significantly larger on the surface of a planet compared to the Sun. The reason the sky is blue on Earth is because of blue scattering. However, this red dwarf barely puts out any blue light at all, most of its light is red and infrared. Also, the denser the atmosphere, the more red scattering replaces blue scattering. The reason the skies are red during the twilight is that because the light has to travel through more atmosphere, the blue light is mostly scattered away, leaving only the red light. On a planet with a significantly higher atmospheric density, this effect would only amplify. As a result, the sky on these planets would almost certainly be red instead of blue. Also, since less energy would be available for plants compared to Earth, they would take whatever energy they can get and reflect almost nothing. As a result, instead of being green like on Earth, plants on such a planet would mostly be black. However, the biggest difference by far would be that since the planets would be tidally locked, there would be no day-night cycle. The entire concept of day and night would not exist on such a planet. The star would appear static in the sky, never moving. There would be no seasons, since the planet's axial tilt would likely be almost zero due to the star's tidal forces. The planets would have higher gravity, but also more oxygen, making respiration easier. Both would probably cancel each other out. Higher atmospheric density would also make flight easier. The day side would be divided into several different climate zones, resembling either Earth's hot deserts, tropical rainforests, or even temperate regions. The night side on the other hand would be very cold, probably an extreme version of Antarctica or Siberia. Civilizations living on the day side would view the night side as this cold, dark, dangerous place that very few know anything about. The movement of the other planets in the sky would be the only thing that local civilizations could use as a calendar to keep track of time. I cannot make any further predictions about how such an alien society or religion would look like. Perhaps an alien religion could assign one god or goddess to every other planet or something. Living on such a planet would feel absolutely nothing like Earth. No day-night cycle, no seasons, no moon, higher gravity, red skies, black plants. It would feel like a horror movie. We humans simply aren't made for any planet other than Earth. But life could exist on such a system, for trillions of years, hundreds of times longer than the current age of the universe.